Question number 19 is a question that we should be able to do with some intuition. So it says, what are all values of x for which the integral from x to 2 is of the cubic function is equal to 0? Okay, so if I sketch this graph, this is an x cubed graph, and we want to know the area from some value x to 2. Now, one of the areas is if we start at 2 and end at 2, the area is going to be 0. So x equals 2 must be a solution to this. Okay, so it's potentially C is an answer. However, because of the symmetry of this graph, we know that this area here and this area here are equivalent, and so we know that if we integrate from -2 to +2, we also get the solution. So x equals -2 will give me 0 area because these two areas cancel out. So the answer is D. So we could do it this way, an alternative way, so I'll call this method 1. The long way of doing this problem would be, and again, this is by far the better solution, the long way is to actually integrate this. So if we integrate this expression from x to 2, t cubed dt, make it equal to 0, that's going to be 2 here, and so we end up with t to the power 4 over 4 from x to 2, make that equal to 0. We end up with 2 to the power 4 minus x to the power 4 all over 4 equals 0. Solving this equation, I get 2 to the power 4 equals x to the power 4. So because it's an even power, I have to make sure I account for the plus minus. So I get plus minus 2 that way. Okay, so this is kind of the longer way of doing it, but using some intuition, we can do it. Just kind of see that the two answers are going to be -2 and 2. For question number 20, this question involves the fundamental theorem of calculus. So we cannot anti-differentiate this function, okay, to get h. And we're being asked here, let h be the function defined by this antiderivative, sine squared t, and which of the following equation for the tangent line, which of the following is the equation for the line tangent to the graph of h at a point where x equals pi over 4. So to find a tangent line, we need the x and y coordinate. So we need to get that y coordinate, and we also need slope. And to find slope, we can use the definition of the derivative. Although we cannot integrate this to get h prime, we know that in general, that if h of x is equal to some integral defined by the area under the curve of f, we can say that h prime is going to be equal to f of x. Okay, so this is a fundamental theorem of calculus. So if that's true, then we can find the derivative, h prime of x. It's going to be just sine squared x. We can work out the value of the slope at pi over 4. So sine squared of pi over 4, that works out to be 1 over root 2 squared, which is equal to 1/2. So there's my slope. All I'm missing is the y coordinate. So to get the y coordinate, I want to find the area under the curve. The value of h at x equals pi over 4 is the area of the curve. So I'm just going to write this out. Is equal to the area of the curve at pi over 4. Yeah, pi over 4 is equal to the area under the curve sine squared t from pi over 4 to pi over 4. Well, if I'm finding the area from pi over 4 to pi over 4, that area must be 0. So the y value here must be 0. So then the equation of the tangent line becomes y equals slope 1/2 x minus pi over 4 plus 0. So when I look at my answers, D is the answer for this question.